hashing. One other cryptographic function related to the blockchain is called hashing. Hashing function takes an input and generates an output of a certain length. For example, you can take this entire chapter on one hand and the word dog on the other, put them through the hash function, and both of them result in a hash of 64 characters. The amount of characters depends on the algorithm used. This characteristic is used to greatly decrease the size of data that is sent on the blockchain. Other characteristics of the hash function, and even the smallest change in the input, changes the output drastically. Apple in lowercase and apple in uppercase result in completely different hashes. This is extremely useful for determining whether a document has been altered without knowing the contents of it. For example, if the ownership document for your house is hashed and put onto the blockchain, then everyone can easily validate whether the document has been altered or not. Now let's say Rob suddenly decides that he is actually the owner of your house and puts his name on the ownership document. This means that the altered document produces a completely different hash, and when it is compared with the original document's hash and they do not match, it is obvious that Rob's document is corrupted. The blockchain network sees this difference easily and can discard the false document, leaving Rob without the rights to your house. Hash functions are also one-way functions, meaning that an output can be easily generated from an input, but impossible to do the other way around. Once something is hashed, the only way to reveal the input would be to start guessing. This, as you might think, is not very easy nor a time-efficient task. And this is exactly the reason why information on the blockchain in the form of hashes is so secure.